Our next program we want to write, lab number 3, write a program that declares and initializes two int variables, one called big, another called bigger, and bigger is going to be one more than big. Print them out and explain what's happening. And by the way, we have solutions. That might give you a hint as to what you might name your program. There's something called an overflow that's going to happen here. I'll use that as the name of mine too, since I'm in a different package. I can use the same name. So new class, we'll do it under labs. I'll call it overflow. And I'll put a main in here, MAIN, control space, enter. And sometimes when you type in code, it doesn't indent like you'd like it to. I want the main to be indented. There's a certain key combination you can use to have your code auto format or auto indent. It's Control Shift and the letter F, F as in Frank. If you do a Control Shift F, it indents your code for you. It's kind of nice. So I've got my main, it's indented. Let's type in here two variables. So int big equals 214,748,3647. I think I got that right. Bigger equals big plus 1. And in Java 7, we can use some underscores to make it easier to read the number. Maybe that's a little easier on the eyes. And then it wants us to print out the value of big as well as the value of bigger. So if we run this, big is that same number we typed in, but bigger, interestingly enough, has a negative value. Well, let's talk about why that happened. And you may already be familiar with something called 2's complement if you've done some computer science classes before, but that's the root as to what's happening here. I'm going to kind of bounce back. I want to show you that that number big was actually the max value of what an int can store. And so when we added one more to it, we ended up at the min value of what an int can store. So integers, 2 billion on either side. Byte would be 127 and negative 128. Let's talk about how this is handled kind of behind the scenes in Java. And so I went out and I grabbed the Wikipedia page for 2's complement because in your computer science classes, if you go out and take them or if you've already had some, this is a way for us to represent our numbers, our integers down in binary format on our system, and it works really well for doing mathematics on it. But anyway, they show a nice little table here of byte, of having 8 bits and how a 2's complement works. What you need to remember is that the leftmost bit here, if it's a 0, that means we have a positive number, and if it's a 1, we have a negative number. So all zeros is a 0, all zeros with a 1 is a 1, 1 0, that's a 2, etc. But if we have all 1s, that's a negative 1, etc., going on up. And so in essence, when we had that max value, when we had done big, we had loaded up, in the case of an int, it was 4 bytes, but we loaded up all 4 bytes with 1s, except for the leftmost bit still had the 0 because it was a positive number. Here we have 127, which is the biggest you can store in a byte, and that 0 means that's a positive number. If we add 1 to that binary number, what ends up happening is that leftmost bit turns into a 1 and everything else turns into a 0. And because of the 2's complement rules, we end up with a negative value. Negative max or min int, if you will, or in this case, min byte. And so same kind of thing happened with us. When we added 1 to that value, we ended up flipping the sign bit, changing that from a 0 to a 1, which takes us negative, and all those other zeros end up being the biggest negative value possible in Java. It's getting really deep into the behind the scenes of how things work. If you are interested, you might want to search on the words integer overflow or 2's complement to read more about how this stuff works.